All right. Now, when we make a decision, we may be doing two errors or one of two errors, of course. Okay. What are these two? We call the first one a type 1 error. What's a type 1 error? Type 1 error happens when we reject the null hypothesis, but the null hypothesis was in fact true. Okay, so we rejected a true null hypothesis. We call that the type 1 error. The other error, you should guess now, what is it? It's called the type 2 error when we do not reject the null hypothesis while it was in fact false. All right, and we did not reject it. We should have rejected that. All right, so let me make it clear for you in a table so that you don't get confused between these two. So what do we have here? The null hypothesis, we know that it can be either true or false, right? There is no other case. And the decision, we only have two decisions. It's either we are rejecting or we are not rejecting. So here we go. This is what we are saying about the type 1 error. When we reject null hypothesis while it was true, this is a type 1 error. Now, when we do not reject the null hypothesis and in fact it is false, then this is a type 2 error. Okay, so what about these two quadrants here? When we reject a false hypothesis, we're good. We did good. And what happens when we do not reject an HO that is true? That's good, right? So if the person is innocent, as we always start, and we do not reject this opinion, we did good. All right. Now let's see how these are translated in the trial example. Okay, so what do we know about the hypothesis? We always thought that the defendant is innocent, right? Until we prove otherwise. Now, this can be, of course, a true or false. So if it's true, that means he's truly innocent. False, no, he's not innocent. He is guilty, in fact. Now, the jury does two types of decisions, of course. Either they will reject their first opinion that he is innocent, and they say that we find that the defendant is guilty, right? So when they do that while he is innocent, they have done a type 1 error. What they have done here, they have convicted an innocent man, right? Or an innocent person. It can be a woman also, right? So this is very serious here, right? Because you are putting behind bars a person who is innocent, in fact. The other decision is what? Is when the defendant, or the decision is that the defendant is not guilty. So if they did it when it's true, that's good. But if they did it when the assumption that he is innocent is false, okay, and they find him not guilty, they have done a type 2 error. Why? What they have done? They have acquitted a guilty person, right? So they sent him free while he's guilty. And like the other table, when they do this decision and it is in this case false, so they are good, and here they are good. All right. Now, the probability to make a type 1 error, the probability, now we're back to talking about probabilities, we denote that by alpha. And we call that the significance level. This is very important key term in hypothesis testing, okay, where in most of the cases they ask you to test your hypothesis at a certain significance level. All right, so you have to remember this term very, very well. Now, type 2 error, the probability is beta. All right, it's beta. Now, alpha and beta are inversely related. So which means what? Which means you can decrease one, but then the other one will be increasing, and vice versa. Unfortunately, we will not have time to talk about that relationship between alpha and beta, because honestly it's a bit complicated concept that I would not like to explain it to you through a video. I prefer that we are in a class when we do that. All right, so I hope that this wrap up the concept of hypothesis testing, the consequences of the decisions, and we are almost there to start really doing a testing for the population parameters. All right, so now that you understand the type 1 error, type 2 error, and how they are related to the decisions, again, I will be maybe the last time I will refer to the judicial system, but honestly, it's very, very important analogy, because I strongly believe that if you understand that context of hypothesis testing in the judicial system, then you will be able to easily understand what we will do next. So in the judicial system, type 1 error is perceived to be much more serious. Why? Because remember what we are doing here, we are convicting an innocent person. So they prefer that, no, they will acquit a guilty person rather than to put behind bars an innocent person. Okay, so that's why they try to avoid that, convicting an innocent person. Because it's really destroy a complete life for the person. Now, and that's why acquitting guilty people is made more possible. All right, and so how this is related to what we have learned, we know that type 1 error, the probability of making type 1 error is alpha. So that's why in order to make less likely that we make type 1 error, we need to have alpha small enough. Okay, so in the judicial system, what they tell the jury that only say that you find the defendant to be guilty only if there is evidence beyond a reasonable doubt. All right. And this is what we're going to do when we are applying the hypothesis testing for our statistical research. Okay, we will talk about that alpha, and we say that we're going to discuss when we are rejecting and when we are not rejecting the null hypothesis based on that alpha value. Okay, so now just to summarize for you, because you maybe now we have covered a lot of concepts and key terms, so it's very good that we summarize everything in one slide so that you can refer to that whenever you feel that you're a little bit confused. So these are the main concepts in hypothesis testing. All right. First of all, we know that there are only two hypotheses. One is called the null hypothesis. The other one is called the alternative hypothesis. And the whole procedure, and you will see that later. I'm going to emphasize that later. How the procedure begins with the assumption that the null hypothesis is true. If you don't have that, in our application, we're not going to be able to proceed. All right, now, what's the goal? The goal is, as we said before, we should find enough evidence, okay, about the alternative hypothesis. Okay, so if that evidence is strong enough, then we are supporting the alternative hypothesis, and in this case, we reject our assumption that the null hypothesis is true. So here we go. We have two possible decisions. Either there is enough evidence to support the alternative hypothesis, remember always that, or there is not enough evidence to support the alternative hypothesis. And ironically enough, you will, even though our focus is about the evidence about the alternative hypothesis, the conclusion statement would be in the terms of the null hypothesis, that meaning that we either reject or we do not reject. All right, but these decisions are based on whether we have found enough evidence or not enough evidence about the alternative hypothesis. Now, we should always recognize that we may be doing errors. Okay, there are two errors. Type 1 error is when we reject a true null hypothesis, and the probability of this error is alpha, and we said that this is called the significance level. And the probability of type 2 error is beta. Okay, and we know that alpha and beta are inversely related. If you want to increase alpha, beta will be decreasing. If usually we want to decrease. If you decrease alpha, we will be prone to a large beta and vice versa. All right, but this is, as I said before, this is something that you will not worry about it now, because we will be working only with alpha in this introductory course. All right, now let's go away from the judicial system application for the hypothesis testing, and let's be back to our statistical inference. Okay, in statistics, as we have been repeating many times, we want to infer about the parameter of the population. Okay, so we want to test the hypothesis about the population. Now, it all starts by a question that comes from the manager or from the researcher. So there's a question that needs to be answered, and this would be our alternative hypothesis. Okay, let me bring you back to the economist example that we did in the previous topic. Okay, remember in that example, the economist wanted to estimate the mean spending of consumers, and let's say, and we did that using the confidence interval. We found the lower level and the upper level, and we said that we are 95% confident that this interval contained the population spending of consumers. Okay, now what if instead of trying to estimate that, we have a certain opinion, or the economist has a certain opinion, and he's saying that I believe that the mean is different than 14,800. Now you may wonder why that's 14,800. For many reasons. Okay, just forget about it and take it like that. Now, how he can then use the hypothesis testing method in order to answer his question? First, he should put that into hypothesis, right? So his question would be translated into the alternative hypothesis, not this one. The alternative hypothesis, he is saying that I believe that mu is different than 14,800. All right. Now, this is not enough, because hypothesis test needs two hypotheses. And now, after he developed his alternative hypothesis, which reflects his question, then it's time for the null hypothesis. And you can see a lot of similarities here. We have mu in the alternative hypothesis, so of course mu here. We have 14,000 here, so we have 14,000 there. And always in the null hypothesis, we have the equal sign for you now for this introductory course. All right, so this is what you need to remember always. We will always use the equal sign in the null hypothesis, and the value in the null hypothesis will be exactly the value, okay, of the parameter which appears in the alternative hypothesis, which comes from the question that you have in mind. Okay.